Good morning, good afternoon, good evening. Whenever you are watching this video, let me welcome you all to our channel Future Endeavors. Okay, so today we are going to discuss few more formation of covalent and electrovalent bonds. Then I think in the next class we will be discussing about the coordinate bond. Okay, so let us see. So if we consider, say, a molecule of a compound like magnesium oxide, okay, magnesium oxide. Now magnesium is a metallic element, whereas oxygen is a non-metallic element. So you can easily understand that when a metallic and non-metallic element they combine, they form what is known as electrovalent bond. How this is formed? Let us see. Magnesium, as you know, has an electronic configuration. It is atomic number 12. So electronic configuration of something like this: 2, 8, and then 2. Okay, 2, 8, and 2. Fine. Oxygen has an atomic number of 8. Configuration of 2 and 6. So magnesium, as you can easily understand, wants to have the configuration of neon. So it must lose 2 electrons, whereas oxygen, in order to attain configuration of neon, must gain 2 electrons. Thus, magnesium atom, say consider the magnesium atom and the oxygen atom. Okay, magnesium atom has 2 electrons in the outermost shell. This is 1 and this 2. Oxygen atom has 1, 2, 3, 4, 5, and 6 electrons in the outermost shell. Okay. Now magnesium, as it has to give away 2 electrons, it will easily donate its 2 electrons to the oxygen atom. Okay. So if it gives away the 2 electrons to the oxygen atom, what happens? Now magnesium atom becomes positively charged. Why? Because it has given out 2 electrons, so it has now 2 more protons than the number of electrons. Okay. So after this, in the next step, we can see easily that magnesium forms a magnesium ion having a charge of 2 plus, whereas oxygen atom forms an ion having a charge of 2 minus. Now these are oppositely charged atoms, positive and negative. As you know, positive and negative charge attract each other. So definitely these atoms will attract each other, and as a result of this electrostatic force of attraction, the magnesium and oxygen atoms combine to form a molecule of magnesium oxide. So this is how you can see that compounds like magnesium oxide, molecules of compounds like magnesium oxide are formed. Fine. Okay. Now let us take another example. Say, so this is an electrovalent bond, ionic bond, because ions are formed. You can see in this state that ions are formed. So this is an ionic bond, definitely. Fine. Now let us quickly move on. Say, let us consider the formation of ammonia. So I think you know the formula of ammonia. Ammonia has a formula of NH3, 1 nitrogen atom and 3 hydrogen atom, NH3. Now nitrogen and hydrogen both can be regarded, or both are non-metallic in nature. So you can easily understand when 2 atoms which are both non-metallic, they combine to form, or they combine by the process of covalent bonding. Okay, so how the covalent bond is formed? Now see, if you consider nitrogen atom, okay, nitrogen atom has an atomic number of 7, so it has a configuration of 2 and then 5, whereas hydrogen has only 1 electron, so 1. Okay, fine. So this is the configuration of the hydrogen and nitrogen atom. Now when you consider the nitrogen atom, it has, this nitrogen atom has 5 electrons in the outermost shell. Okay, so 1, 2, 3, 4, and then 5. Now in order to have the stable electronic configuration like that of the neon, it must have 3 more electrons in its outermost shell, so it has to acquire further 3 electrons. As I have said, it is more difficult to give away those 5 electrons than to accept 3 electrons. Okay, so now here comes one hydrogen atom with a electron in its outermost shell. Fine. Now this hydrogen atom shares its electron with the nitrogen atom. So a shared pair of electrons appears in between the nitrogen and hydrogen. On the other hand, see, another hydrogen atom comes with its one electron. It also shares its one electron with the nitrogen atom. So another pair is being shared. Now see, at this step, how many electrons does nitrogen atom can have this outermost shell? It has its own 5 electrons, 1, 2, 3, 4 and 5, and 1 electron of this hydrogen atom, 1 electron of this hydrogen atom. So it becomes 7. So it needs one more electron. Now, how it will get acquired that one more electron? Another hydrogen atom comes into the scenario. Okay, so another hydrogen atom comes. So another hydrogen atom with one electron in its outermost shell. Okay, comes. This hydrogen atom also shares its electron with the nitrogen atom. In this way, what happens? Nitrogen atom, by sharing 3 single electrons with 3 other hydrogen atoms, get to have 8 electrons in the outermost shell. See, one thing is there, here the electrons are not totally given by the hydrogen atom to the nitrogen atom, so no ion is being formed. Only, also on the other hand, nitrogen does not totally take out the electrons from the hydrogen. They are just sharing. Okay, nitrogen is sharing the 3 pair of electrons with the 3 individual hydrogen atoms, and thus it fulfills the criteria of having 8 electrons in the outermost shell. So we can read all this structure something like this. I hope you have noted the step. If not, please pause the video and note it. Okay, so the structure can be drawn something like this. This is one nitrogen atom. Okay, let me draw it a little big. Now with this nitrogen atom comes another hydrogen atom like this. Below another hydrogen atom like this. Okay, and from this side also another hydrogen atom like this. Okay, now nitrogen atom has itself 2 free electrons in its outermost shell, 1 and 2, and another 3 electrons are shared by the nitrogen atom with the other 3 hydrogen atoms. So if you consider the hydrogen atoms individually, they have 2 electrons in the outermost shell. See, the 2 electrons are present in the common space, whereas the nitrogen atom has also 8 electrons. How? 6 electrons are already present in the common space and 2 electrons present in its own shell. They are not shared. So this kind of formation takes place, this kind of structure is being formed by the nitrogen atom with the hydrogen atom to form a stable molecule of ammonia, NH3. So I think the concept is clear, overall concept. Okay. Now here I must say one thing. This nitrogen atom has one pair of electron unused. One pair of electron unused. Okay. Remember, we will be discussing about this. This pair of unused electron is called lone pair of electron. It's called lone pair of electron. Okay, lone pair of electrons. So this lone pair here has no utility. It does not participate in any kind of bond. It is just present in the outer orbit. Okay, but it does not leave the orbit. It remains in the orbit. So this is the formation of ammonia molecule. Okay, can we take another example? Yes, let us take another example. A quick example. Let us say consider the formation of methane molecule. Okay, methane. You know the formula for methane is CH4. Formula for methane is CH4. Okay, so carbon atom, atomic number 6, configuration of 2 and then 4. Hydrogen atom has only 1 electron, so it's only one shell like this. Now the carbon atom, so let us see the structure of the carbon atom. Okay, the carbon atom has 4 electrons in the outer shell. Okay, so 1, 2, 3, and then here 4. Here one hydrogen atom comes, okay, and this hydrogen atom shares its electron with this carbon atom, so one bond is formed. These are all single bonds, as we have studied. These are all single bonds because only one pair of electron is formed. Another hydrogen atom comes here. 4 hydrogen atoms appear. Okay, another hydrogen atom comes here, and another hydrogen atom comes here. Now, this hydrogen atom also shares its one pair of electron. Okay, this hydrogen atom also shares its one pair of electron. Also, this hydrogen atom shares its one pair of electron. Like this, 4 pair of electrons are being formed. Okay, and the carbon now has 8 electrons, 4 electrons of its own, and other 4 electrons are being shared by the 4 hydrogen atoms. In this way, the structure of methane is formed, and if you just read out the structure, it looks something like this. So here is the carbon atom. Okay, overlapping with it is the hydrogen atom, one hydrogen atom here, another hydrogen atom here, another hydrogen atom here, and another hydrogen atom here. So these are the hydrogen atoms. They are sharing their electrons, cross dot, cross dot, cross dot, and cross dot. Okay, so I think the concept is clear. So this is how methane molecule is being formed. Okay, so with that we come to the end of our class today. We will be carrying on the next class, the coordinate bond, talking about in details. So if you have any query, please do mention in the comment box. Thank you. Goodbye.